I was drinking a proper Italian espresso, minding my own business, when something suddenly caught my eye on the screen. This Casper guy clearly knows what he is doing. Not bad for a ghost, honestly. But I think I can do better, so let's roll up our sleeves. Challenge officially accepted. First, erase the default cube, open this window, select Spurt Shock, and create a brand new node setup. Then create a new plane and rotate it by 19 degrees. Select these two vertices and scale them slightly. This shape may look simple, but it is doing more work than it seems. Now get the node called getObjectData. Yes, there are many gets here. Hide the plane for a moment and trust the process, at least for now. Let's get a polygon face node and connect it to the getObjectData node. Then add an extrude face node, connect it, and change the direction. Otherwise the geometry will look like smashed toast. Unhide the plane, select it, move it to center the object, and then lift it up. This alignment step is boring, but skipping it will punish you later. Now get a box solid node to tidy things up, because solids like things clean and ordered. Modify the dimensions of the box so it matches the base of the object. Take a moment here, because from now on booleans will start flying everywhere. Grab a solid Boolean node and join the base with a pyramid. Get our favorite fillet node. Then add a solid element select node to select the edges pointing upwards. After that, connect the edge mask output to the fillet mask input and carefully adjust the fillet value. Now let's create a cylinder and modify it using the transform solid node, because later we will need the same cylinder, centered and scaled, to subtract geometry. Rotate it using Euler angles, changing y values to 90 degrees. Then move it back and up to form the upper part of the piece. Scale it on the x and y axis to make it smaller and on the z axis to make it longer. Add another solid Boolean node in union mode to join this part to the top of the object. Whenever you see me creating a temporary viewer, it is not magic. Just Control and left-click on a node. Create another cube, which will be used to carve the hollow part in the center of the object. This cube exists only to be removed, so do not get emotionally attached to it. Grab another fillet node and mask two bottom edges. I first check which edges need filleting. Then I note the indexes and use a list input node to feed them in. Of course! After that, add another solid Boolean node in difference mode to subtract this filleted cube. At this point, the geometry is starting to look really clean. Now grab a cylinder and change its color to green, just to highlight that this is geometry we are about to add. Change the angle to 180 degrees to cut the cylinder in half, then rotate it on both the Z and X axes by 90 degrees and move it back to align it with the base. Scale it slightly and move it down until it matches the bottom face of the base. Add another solid Boolean node. Here you can see an interesting intersect result that I created by mistake before switching to the correct mode. Now comes the interesting part. Sverchuk scales objects from the center of the world, so scaling also moves them. To avoid this, I reuse the same matrix used to position the cylinder and connect it to a matrix deform node, so the cylinder stays perfectly in place while scaling. After that, apply a solid Boolean in difference mode in Tata. The magic finally happens. Create another cylinder, which will be used to make the holes at the base, and carefully scale and position it. Yes, this is another cylinder. This project contains more cylinders than I originally planned. Now add a mirror node to create the other 3 holes. But before continuing, subtract the first cylinder to preview how the hole will look. It looks good. Duplicate the Boolean node, connect the mirror output, create a matrix, and rotate the mirror plane by 90 degrees on the y-axis to preview the mirrored result. Join these 2 cylinders together with a solid Boolean node. Then apply another mirror node to duplicate them on the other side. Rotating the mirror plane by 90 degrees on the x-axis. Finally, apply a Boolean difference to preview the final result. Look how clean it is. This is one of those moments where solids really start to shine, and everything just clicks. I was looking for this cylinder. As I mentioned when I first created it, I knew I would reuse it later to make the hole in the upper part. To do that, I use again the transform solid plus matrix deform method we used before. I simply grab the matrix applied to the first cylinder, plug it into the matrix deform node input, and scale it on the x and y axes. After that, apply a solid Boolean in difference mode and tada, we get a perfectly centered hole. Create another cylinder. Yes, this is really the last one, I swear. Position it carefully and subtract it to refine the shape. And here it comes. I know you were waiting for it. Drum roll please. The Evaluate Curve plus Index Viewer setup. Grab a solid edge node to duplicate the edges of the object, connect it to Evaluate Curve to convert curves into mesh, and finally connect everything to the Index Viewer node to visualize the actual indexes. Do not forget to enable the option to draw object indexes. In a perfect world, this would be a single node called Solid Index Viewer. I am studying how to code it, but programming and I are not best friends. Once everything is set up, add a fillet solid node together with an index to mask node and set the fillet value to something nice, like 0.002. Here I change the transparency and color of the indexes to better read the geometry underneath. Finally, add a list input node and list all the indexes corresponding to the edges we want to fillet. I speed this part up because it is mostly about reading numbers and typing them in. Not the most exciting part of the video, but definitely one of the most important ones. Look how beautiful this geometry is. Now select the final temporary viewer node, set surface deviation to 0.01 and angle deviation to 5. Then click on Bake to get a smooth and clean result. This is amazing, I am very satisfied. What do you think? Is this comparable to Casper's result? Let me know in the comments and consider subscribing if you enjoyed the video. In the next video, I plan to explain why working with solids instead of meshes is so important if you are a maker, designer, or engineer. For now, just enjoy this beautiful section. Thanks for watching, and see you in the next video. Bye!